Next chapter. Right, ray optics. Many things has to draw, many things has to, so pen, pencil, all. Ray optics. Simple chapter, easy to study. Okay, not very difficult. Padikana madri padisna easy. Already studied in the schools, right? So little bit. Already studied in schools, so many things you know. Already studied in schools and somewhere, right? Many things you already studied, optical instrument, image. Right. Okay, we'll start. So first write a subheading, optics. Optics is the study of light. This everybody will write it first, then only the real pain will start. Concept clear you will yourself will answer. That is nothing. You can see the difference. If I answer one thing, next thing you will answer. Okay, optics is the study of lights. Now optics, normally two types of optical study will be there. One is called wave optics, another one is called ray optics. Ray optics is also called geometrical optics. So right, optics is classified into two. This will never ask for entrance examination. Optics is, but we want to know what we are studying, right? Optics is classified into two. First one, geometrical optics, and second one, wave optics. Geometrical optics, and second one is wave optics. What is this geometrical optics? What is geometrical optics? Okay, so this ray optics is also called geometrical optics because the size of the ray is comparable to the size of the measurement of the object. Anything understood? No. What we are taking the measurement. For example, we are studying about a mirror. Okay, every day we are looking for mirror, right? Morning before coming to class. Okay. So the size of the mirror is measurable. Correct? Size of the mirror is measurable. We can measure certain things. Geometrical. In your geometry box, compass will be there, protractor. A lot of things will be there in the instrument box, right? Everything is a measurable device. So here also we have many measurable equipments will be there. For example, scale. We need scale is a measurable equipment. Mirror, we can measure the length. And geometrical tools use you can also measure. You have done some experiment in +2 lab. Yeah, at least something you have done. Some values you got, U, V, something like that. Correct? So you have done certain measurement. Everything you are measured using scales, right? There you have scales and you have something and you have turning and you are calculating certain size in centimeters and all you are doing. So which means we can measure something with the help of certain instrument which is called geometry because it is connected with the mathematical geometry. But in case of wave optics means you cannot measure anything your own. Okay, with the help of certain equipments we cannot measure. And in ray optics we are using Newton's corpuscular theory of light. Which means that what? Newton first told light is in the form of a ray. Okay, or in the form of a particle nature. Then later when wave theory of light is coming, then the science will be told no, light is not in the form of a wave, light is not in the form of a particle, light is in the form of a wave. Who told that? Young's double slit experiment, then Huygens wave theory of light. These all theories later time in 1900s, close to 1900s, it is told light is not a particle, light is a wave. Then again after 50 years back, again science told that light is a wave, that is correct, but at the same time light will have a particle nature. Again the Newton theory is proved as correct. Okay, So who told light is in the form of a particle in the recent centuries? Who told? Einstein photoelectric effect. Okay, so initially the story is coming like that. Initially Newton told light is in the form of a particle. Then science is asking it is what kind of particle. He told it is in the beads of a chain. Okay, a chain will consist of lots of beads, right? So that beads of a chain, the light is in the form of a collection of beads. So it is a particle. He told like that. Then later, after there, 200 years back, after once his life is expired, then Huygens theory, then Young's double slit experiment proved that light is not in the form of a particle, light is a wave theory. They are proved through experiment and certain calculation, blah 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 things will be there. Okay, so based upon this one, it is proved that light is in the form of a wave. Then Newton's theory is completely rejected. Newton corpuscular theory. So Newton is very famous in mechanics part. Newton's law of gravitation, Newton's laws of motion. But once you come to second year, you are very rarely hearing about Newton, right? First year you are hearing about Newton in various places. So electrical side, magnetism side, modern physics side, Newton contribution is very less. Why? Because its contribution is very less. Because he's very old here. In mechanics side he is very young. When come to here he is 80 years, 90 years old. He cannot contribute much, right? So that is the thing. Nothing wrong will be there. Then Newton's theory will be getting reflected. Then in 1940s and all, again this Einstein photoelectric effect theory state that light is having particle nature also, he told. Then he proved using photoelectric effect phenomena. So now science is going in the direction that light is having particle nature, light is having wave nature, light is having two natures. That's what it is called dual nature of radiation. Okay, you are learning dual nature of radiations. So that is the concept behind this one. So first thing, now we are going to study Newton's corpuscular theory. Newton told light is in the form of a particle. So here we are learning everything with respect to particle nature. We are not at all thinking about wave nature. Then we will learn about wave optics. There we will speaking about light is in the form of a wave. Then we are learning about a dual nature of matter and radiation. There we are speaking about light is in the form of a wave and light is in the form of a particle. Two things we learn. Okay, so now we are in the first, in the very old age. Okay, light is in the form of a particle. What we have written now? Geometrical optics and wave optics. Now you understand what is called. So geometrical optics, next one. Geometrical optics is nothing but ray optics. Geometrical optics is nothing but ray optics. Light is considered to be particle in nature. That is Newton's corpuscular theory. Newton told these particles are called corpuscles. The important Allah, it will never ask. Okay, but particle nature. Okay, next we'll jump into the deep sea law of reflection. Law of reflection, the first topic. Law of reflection. What is law of reflections? First one, right? Incident ray, reflected ray, and refracted ray. Never miss the class. Once you miss the class, you will never understand the next class. Incident ray, reflected ray, refracted ray, because in the next 2 more days I will continue, right, as per the schedule. So incident ray, reflected ray and refracted ray are in the same plane. Sorry, not refracted ray, normal. Sorry. Incident ray, reflected ray and normal are in the same plane. Second one, angle of incident is equal to angle of reflection. Angle of reflection. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflections. See, this is a plane. Okay, and listen, once you marked a plane something like this one, this is indicate this area is opaque. One minute, this area is opaque, which means it will not pass light into the other side. So this is an incident ray, and this is called normal ray. Normal ray makes how much degree with the surface? 90 degree, and this is going an reflected ray. And angle of incident is the angle between incident ray and the normal ray. This is called I. An angle between normal ray and the reflected ray is called R. So angle of incident, the incident ray, refracted ray and the normal ray, this is in one plane. This is in single plane. This is one surface, this is another surface. So this is called law of reflection. I is equal to R. If I is equal to 30 degree, R equal to 30 degree. Okay. Now the diagrams are simple. Once you are going ahead, diagram will become bigger. Complexity will also become bigger and bigger. So use some colors to identify which one is the correct one. Okay. Now it is simple. You can use in the same way. Okay. Next one, object. What is called object in a simple way? You can imagine you are standing in front of a mirror. You are the object. You are the object. Okay, you are standing in front of a mirror. You are the object. So object is something which is placed in front of a mirror or in front of a lens. Things we are going to study mirror, lens. Okay. So the object means what? It is a matter. It is a matter placed in front of mirror or lens. Mirror or lens. What is called an image? Image means you are seeing your photo in the mirror. Correct. That is called image. So image is actually forming intersection of reflected ray. Intersection of reflected ray forms image. Intersection of reflected ray forms image. Intersection of reflected ray forms image. We will see what it is called. So let's start the next heading. Image formations by a plane mirror. From here onwards, the real things are starting, and the question, how it's coming for the entrance examination, the same thing. Image formations by a plane mirror. So first topic is plane mirror. Then we will learn about a spherical mirror, concave, convex mirror. Then we'll go to lens. Then we'll go to biconcave, plano-concave, biconvex, plano-convex, optoelectronic device. Okay. So image formations by a plane mirror. Okay. The first subheading, two subheadings will be there. Point object. Point object. Okay, so how to draw the diagram? This is important. So listen to the board. Okay, point object means just one dot, just one coin mile. This is a plane mirror. This is a way in which we are drawing the diagram. If you are able to draw the diagram, you are able to find the answer. That's all. Okay, if this is at a d meter away, an object is placed, will be here. This dot. You can draw any number of lines. The first property will be here. Any ray from here, you can assume like this is an object, or this is just like a coin. A coin is placed. So if an ray is coming from this object going perpendicular 90 degree to the mirror, then this will be getting, what will happen? This will be getting reflected back. So if it is going perpendicular to this one, then for this is a mirror case, This is called the normal ray, correct? And this is the ray which is called incident ray. So what is the angle of incidence will be here? 0 degree. Okay, and the reflected ray after hitting on the mirror, this is coming back. So what is angle of reflection is also 0 degree. It's on the same line. So which means if a line is going and it is reflecting back. Okay, so now to get an image formation, you need minimum 2 lines. Okay, intersection of the reflected ray. Here it is d meter, means you can represent d meter towards right side. Okay, next one, this is one line. Okay, so d meter here means d meter there also. You are seeing your size will be exactly same in the mirror also, right? Okay, it's not zooming, it's not zoom out, both the same. If a ray is going like this, for example, this is what ray? Incident ray. So I will draw a normal to the ray, and incident angle with the normal to the ray is called angle of incidence, is equal to what is called angle of reflection. So the ray is reflected and this is angle of incident is equal to angle of reflection. This ray, if you extend, it will meet here. So 2 rays are meeting. This reflected ray you extended, it meet here. This reflected ray you extended, it meet here. And this point is called image. Okay. Behind the mirror is an opaque device. Opaque means other side nothing, you cannot see. So here this dotted line is representing, means there is not physically we have a coin, but you are seeing a coin on the mirror. Actually the coin is there in the mirror? No, it's not there, right? We are seeing a photo kind of thing. So that is called image. This nature of image which is not really present there, this is called virtual image. Virtual image, you are seeing something. So to get an image, how many lines are minimum required? 2 lines, 2 intersections are required. Now this line crosses with this line at this point. So this is the point at which the images is forming. Next, for example, now I have this point, I have this coin again. I am drawing one line like this. So what will happen? It will be get reflected back. Okay, and the reflected ray is extending. How much I have to extend? If this is x meter distance, I have to extend this also x meter. So at x meter is the line which is going like this one. Okay, or minimum case it is exactly at x meter the image will be formed here, I know. But to get more clarity, I can draw one more line, and this will be hitting on this mirror, plane mirror. So we have what is called angle of incidence here, I, and this ray is reflection going back, and what is this angle is also called angle of I am extending this line and meeting here. Similarly, maybe some other light is coming here, and this is a ray which is hitting over here, and this is we are drawing a normal ray, and the normal is making how much is the angle of incidence, and this is the reflected back, and this ray is called angle of reflection. Incident is equal to reflection, both are same, and this is a reflected ray. This reflected ray you are extending back at a meeting at this point. So now here how many intersections? 3 intersections. 3 all will be meeting on a same point, and this point is called what image? Virtual image. Virtual image. To form an image, minimum how many lines are required in case of a plane mirror? Minimum. Not 2 is required. 2 is required. Of course, we need to get intersections. But with the one line itself, you can say where the image is occupied. Correct? If it is d meter away, definitely sure that it is d meter away will be here. So this is called a point object. Okay, you can draw any number of lines. Here, one ray straight and one ray return back. One line. And this is one incident and one reflector. So 2. These 2 lines are meeting at this point. But in this case, how many lines will be there? Totally 3. One is incident, one is reflected. One pair. One is incident, one is reflected. Second pair. One is incident, one is reflected. Third pair. All are extending will meet at the same point, and this is the image format. So without this pair, with this pair alone also you can say image is at how much distance? X meter away. So image is not enlarged image. Enlarged means zoom out image. Image is not diminished. Diminished means zoom out, smaller one. So this is not smaller one, this is not bigger one. What exactly you placed here, you will get exactly the same thing will be here. Okay, this is called, this is a point object. We learn about next about extended objects also. Extended object means it's a bigger size object. Now this is a small object. Okay, so to get an image of an object, how many minimum pair are required? One pair is enough. One pair is enough. With the two pair also you can find. With the three pair also you can find. If you want, you can draw many lines. Reflection, angle of incident, angle of reflection, angle of incident, angle of reflection. Any number of lines you can draw. But everything will be meeting at a common point. For example, this is one line. You are drawing. It is meeting at here. You are drawing and meeting angle of incident, angle of reflection. Meeting at here. Angle of incident here. Angle of reflections here. Okay, so this is also meeting will be here. If you want, still you can draw like this. This will meet here. Angle of incident, angle of reflection. Angle of incident, angle of reflections. But all the lines are meeting at a common point. And this point is called a virtual image. You can draw any number of lines. Here that is example of drawing 2 lines. This example of drawing 3 lines. Example of drawing n number of lines. You can draw any number. But image will be formed on which side? On the other side of the plane mirror. Understood? Then draw this stuff. At least this and this you have to draw. Okay. Please use some other colors, something like that. This side should be a dotted line. Dotted is indicating virtual image. Image is not physically present. So one pair is enough to find out where the image is located. Okay, this one and this one you can draw. Oh, oops, I forgot this. Image formations by a plane mirror, point object. You can draw yourself once you understand this one, you can draw that one, right? That's very easy. So you can draw any number of incident ray and any number of reflected ray. So all the lines will definitely meet at a common point. That point is called image. Okay. find the coordinates of image where the image is formed. Find the coordinates of the image. Find the coordinates of the image where object is placed at the position coordinates 2, 0. This is a plane mirror. Correct? A plane mirror which is placed at an angle of 45 degree. The 45 degree object is placed at a coordinates of 2, 0. This mirror is placed like this one, where the image will be formed. Where the image will be formed. How to do that? To form an image we need one pair. Okay, that pair should be perpendicular to the plane mirror. Correct? Perpendicular to the surface, or the angle of incidence will be equal to 0 degree. So in this case, what you want to do means you have to extend this mirror. This is the plane where the mirror lies. Okay, so now this is a line which is coming perpendicular to the mirror, or angle of incidence, and there is an angle of reflection also. Angle of reflection. Now what is this distance will be here? If this angle is 45 degree, what is this angle? 45. This angle is perpendicular 90 degree. This angle is 45 degree. So this is an isosceles triangle. Two sides are equal and the other side is different. So 2, 0 means this side is 2. Correct? This side is 2, x coordinate. What is the length of this side? What is the length of this side? This angle is 45. So adjacent side 2 cos 45 degree. 2 cos 45 degree. So 2 into cos 45 means 1 by root 2. Answer equal to root 2. So this length is equal to root 2. So object is at a distance of root 2 meter away from mirror. So image is also the same distance here somewhere. That is also how much meter away? Root 2 meter away. Root 2 meter away. Now the total distance is how much? Root 2 plus root 2. Correct? This is a right angle triangle here. So right angle triangle. This distance is root 2 plus root 2. How much will come? 2 root 2. And this side is 2. This is a y coordinate, y position. I need to find this one. How to find out? This is called x. So x will be equal to root of, tell me, 2 root 2 the whole square minus 2 square. So how much will come? 4 into 2 minus 4, 8 minus 4 root, which means root 4, which is equal to 2. So this is a y axis downside. So the coordinate will be 2, 0 means I can written as minus 2, 0. So the image is at a distance of minus 2, 0. This is an incident ray and this is a reflected ray. Sorry, 0, minus 2. 0, minus 2. Y coordinates. So x is 0, y is minus 2. Understood? So ഇതാണ് വെക്കുന്ന മിറർ. ഈ മിററിനെ ഇങ്ങനെ എക്സ്റ്റെൻഡ് பண்ணி you can think about it. Okay, you can extend the mirror. ഇത് ഒരു പീസ് 45 ഡിഗ്രി വെച്ച്. So ഇതേപടി ഇത് ഇങ്ങ ഇരുന്നാലും സെയിം എഫക്റ്റ് தான். Okay, because the mirror should be along this line. അതാണ് അതിന്റെ മീനിങ്. Because one portion of the mirror is showing means you have a provisions to extend it. You can extend, but you are not supposed to tilt it. So 45 degree വെച്ചാൽ object is at 2, 0, image is at 0, minus 2. Okay, this is a previous NEET question. Okay, 2012 or 2013 on the time. extended object. A point object and we have learned. Next one is extended object. Extended object means what? We have not only one object, we have a size. We have for example, let me take an example. Suppose this is a mirror and you have an object of this much size, head and tail. So this is having size A to B. AB is the height. Okay, so how you will get the image? You can consider like both end like a point object. You consider this like a point object. So what you will do? Incident ray, reflected ray. If this is d meter away from here, if it is just d meter away, then what you will also get, if you are extending this line, you will get what lines? You will get an image will be here. This image is at what distance away? D meter. Head become head only here, head only. Okay, then tail will be there. This also incident ray and hitting and coming back, reflected ray, you are extending this, and here you will get the foot of this one. Okay, this is like an object and this is a point object, 2 point object connected, and you got 2 locations where images are formed at a d meters away. Now you just connect these 2. So now you will get the image which are forming over will be here from A to B is called A dash to B dash. Okay, just one line is enough. Even though if you want, you can also draw like this. Incident ray, reflected ray. If you extend, it will meet here. Incident ray, reflected ray. Incident ray, reflected ray. If you extend, it will meet here. You can draw any number of lines. So let's have like this. If you have an object A comma B, it's tilted like this one. So how will be the image will be formed? This you can consider like an object, incident ray and reflected ray. This distance you will get an arrow mark. Correct? At this point you will get an arrow mark. Similarly, this is a tail. You have an incident ray and you have an reflected ray, and you are also extending this line. You will get some other points will be here also. So how the lines look like this, A comma A dash comma B dash. So this distance are equal. If this is x, this is also x. If this is y, this is also equal to y. Next one is small subheading, clock problems. Clock problems. Clock related problems. what is this time in a clock? 3 o'clock. Who is told 4 o'clock? Okay, now if you are giving a 3 o'clock and you placed a plane mirror, what you will get it? He will be here 9 o'clock, which means both will be getting rotated, or this will not rotate, right? This will be like this. So this is become 9 and 12. This is 12 and 3. Okay, so 3 o'clock become 9 o'clock. So plane mirror, there is a shift. So 3 to 9 shift will be there. Okay, so how to find from 3 to 9 shift? 3 o'clock to 9 o'clock, how you will find it? You have to subtract what is the value which is given will be here. It's a 3 o'clock. So 12 hours you have to take the difference, 12 hours, which means 12 hours minus 3 hours. You will get the mirror value which is here, 9 o'clock. Understood? You have to take a 12-hour difference. 12 hour you have to subtract what's the value coming here. You subtract that value, then you will get. If you see 3 o'clock will be here, 12 minus 3 you will get 9 o'clock. Okay, similarly the plane mirror, the clock will be a 12 hours shift. Right, one question. Find the time shown in the mirror. Find the time shown in the mirror by a clock which reads 2:35:05. 2:35:05. That is 2 p.m. 35 minutes 5 seconds. This clock you are facing in front of a plane mirror. What you can see in the mirror? What you have to do? You have to subtract 12 hours from here. 12 hours means what? 12 0 minute 0 second minus of 2 minutes 35 minutes 0 seconds. You have to subtract this one. 0.5 seconds. Then minus 9 25 55. Correct. Here 0 means 60 seconds. Simple. 60 seconds in 5 seconds minus 55 seconds. 60 minutes in 35 minutes minus 25 minutes. Okay. If a clock full 60 seconds. So 60 seconds minus 5 seconds means 55. Correct? 60 Aslam, correct? 60 seconds minus 35, 25. Here how should 9? Why not 10? Passing. This is 10 pass.
Sir, 20.
24. Which one? Huh? How 24? Overthinking now. Simple. 60 seconds, 5 seconds, 55. 60 minutes, 35, 25. 60 pass. So 11 minus 2, 9. Huh? 59. How many seconds will be there in 1 minute? 60 seconds. 5 seconds lost. 5 seconds reduced from 0, 0, 0. Where also you go? It is not like a normal subtraction. 10 എടുത്ത് 9 വരും അങ്ങനെയല്ല. Okay. Clock maximum 60. Below, right? A boy of height. A boy of height. A boy of height, capital H meter. A boy of height, capital H meter. Want to see his full image. Want to see his full image in the plane mirror. Want to see his full image in the plane mirror. The minimum size of the mirror required for this is dash. How? Then I will ask one more question. I will ask the next question. This you are correct. Tell me. Okay, nothing. So you are correct. It is half of this one, but not always. Okay. A to B. Okay. A person whose eye position is located here, having a height equal to h. This is a method of solving this one. This method has to remember. This question will never ask. Other question will ask. I'll tell you how it's coming. So this is the eye position. Okay, if a person who is looking, and here we have kept a plane mirror. Okay, so this is a head and tail, as I told. So there is a reflected ray and image ray. Okay, so this is the ray which are coming, and this is coming over here and accepted by the eye. Incident ray and reflected ray. Reflected ray is seen by the eye because the person has to see the full size of the object on the mirror. What is the size of the mirror? That was a question. So this is his head. Head in the first ray, it's hitting on the mirror and it's absorbing to the eye because he has to see his head and to the foot. Similarly, the ray which is coming from the foot, an angle of incidence will be here, and we have an angle of reflection is also there. So this is an angle of incidence and this is an angle of reflection. Reflections are always coming to eye. Okay, I can see you because the light is coming and hitting on your body, then reflecting to my eye. So similarly, eye is the receiving side and the object is the where the light is hitting and coming back. Okay, so eye is the receiving point. Now how I can plot the what I can say, the image formation. Image is the extension of what? Reflected ray. So the eye is will be here. So eye is some distance away. So incident ray and reflected ray. So I is also in the same distance. If this distance is marking as L meter, then in the image side also L meter away I will be located. Correct? So this E will be here. This is given as E dash. Correct. Next one. This is the reflected ray. This reflected ray I am extending. This reflected ray I am extending. And here also this is an incident ray and this is a reflected ray. So this reflected ray is also extending. Two things extended. So this is going to lead, this is a line and this is a reflected ray from where? B. So somehow it will give rays to B dash. I'll come to that point at some point. I don't know where it is. But the A, incident ray and reflected ray, extended the reflected ray, and I got what's the point? I got some point which is called A dash. Complete up to this. It's understood so far how it is done. E on the line, this is IA at a distance of L meter, incident ray and reflected ray, and this is also L meter away, E dash. So E dash I got it. Now I have a point called A dash and B dash, but I am very sure this A dash and B dash line should pass us through where? Passes through E dash, correct? E dash. So the point A dash will come here and the point B dash will come here. So A dash and B dash are located. So complete this diagram. A is giving rays to an incident ray which is reflected and coming to I. B is giving an incident ray which is hitting and reflecting and give rays to E. So A and B are the object and E is the eye. So one more ray which is going parallel and coming parallel. That is E at a distance of L meter. So L meter away, E will be there, E dash. So I know A dash is extended line and B dash is also an extended line. So all these lines are in a same line, A dash, E dash and B dash. Okay, next one. The length of, now A, B is the object. What is the image on the other side? A dash, B dash will be the image. So to get AB is the object, A dash is the A dash and B dash will be the image. To get that full image, what is the size of mirror? This much size is required. Now I have taken this much size. These are waist. This upper side and lower sides are waist. Only what is length? If I am giving this as this length as X and this length as Y, then what is the size of the mirror I required? X plus Y. Okay, so then below, right? X plus Y is the size of size of mirror required to have the full image, A dash B dash. Okay, now here I am considering like a two triangle to get some calculations. One is this one. You can see the triangle. One is this triangle like this. E dash, A dash. This is a triangle. And there is a center cut will be here and this is X which is at a distance of L meter and L meter away. Correct? So A dash to E dash is the image header to image I in length. Correct? This triangle is simulated here. Next, similar triangle concept will be there. What is that? I am writing as A dash E dash divided by this height divided by this height. X is equal to the full length divided by this length. So how much I can write as 2L by L. This is correct? Yeah? A dash E dash, biggest height minus smallest height is equal to biggest length minus smallest length. Similar triangle concept. Okay, this triangle is similar to the full triangle. So A E dash divided by X is equal to A E dash in the length 2L divided by X in the length L, 2L by L. So what is A dash E dash is equal to 2X. Okay. Similarly, I am taking the lower triangle. Lower triangle also taking. This point is E dash, this point is B dash, this point is E. So here we have Y, L meter away. So how I can write as E dash, tell me, E dash B dash divided by Y is equal to E dash B dash in length 2L divided by L. So E dash B dash will be equal to 2Y. This step is important because the steps we are using on some other problems. Okay, so next one, size of image is equal to how much? A dash B dash, which is equal to A dash E dash plus E dash B dash, correct? Size of the image, the full size, A dash to B dash, A dash E dash plus E dash B dash. So how much this is coming? 2X plus 2Y. Or I can say 2 into X plus Y. 2 into X plus Y. This is size of image. What is X plus Y? Size of the mirror. So size of the mirror is half the size of image. So below write size of mirror is equal to, size of the mirror is equal to half the size of object, half the size of image. Size of the mirror, which means we know this is called x plus y, is equal to half the size of object, half the size of object in the size 2x plus 2y, 2 common and a cut out. In a plane mirror, size will be varying. Size is not varying, right? Size of image equal to size of object always. In the previous question also we have seen, we have drawn something like this one. We placed a plane mirror, then we'll got a line like this one. Size will be the same. So below, right, size of image equal to, size of image is equal to size of object, which is equal to size of image plus size of object is equal to x plus size of mirror is equal to size of object. No, not correct, sorry, whatever you have written previously is correct. Size of image is equal to size of object is equal to 2 into x plus y, 2 into x plus y, which is equal to 2 times size of mirror. Size of mirror is x plus y. Okay, clear up? So either 2x plus 2y ആയിരിക്കും, x plus y, half the size of the object. Object in the size, mirror the size similar, but here it's bigger, right? Whatever I drawn. So anyway, the size of the mirror is half the size of object. Then we can see the size of the, then we can see the full image of the objects. It's clear, huh? Then write one question. A boy is standing midway between wall of height h and a plane mirror Find the minimum length of the mirror. Find the minimum length of the mirror to see the complete image of the wall. How to do? Diagram construct ചെയ്യണം, അതാണ് highlights. The boy is standing at a midway between a wall and a plane mirror. But what is the aim of the boy? To see the full wall. Can you draw? First the wall, then a boy, then a mirror. Okay, this method is what we have done, but step by step construct ചെയ്യണം. Okay, we will draw it together, huh? Yes. This is a wall, okay, and this is our plane surface. So a boy is standing over here, okay, and this distance is d, for example. I don't know, nothing is given in the question. Distance is d, but height of the wall is only given h. What's the size of mirror? And mirror is what distance away? D distance away. Why?
He's in the middle.
He is standing in the mid. So now I placed a mirror. I don't know what is the length of the mirror. I placed simply a mirror like this. But what is he saying? He want to see the wall, the full wall he want to see. So what should I will do? I need an incident ray, I need a reflected ray. So incident ray after reflection will come to where? Eyes. So head എന്നൊരു ലൈൻ വരക്കണം. First line, draw a line from the head. A line which is coming from the head like this somewhere. Okay, anywhere it will meet. So this is what ray? Incident ray. So what you have to draw will be here? Normal ray. So angle of incident will be equal to angle of reflections. Definitely you know it will come to your eyes. Next one is what? We have to extend this line, right? We have to extend this line. So I am extending. I am extending. I am extending. Okay. Next, what are other things are required? This is one line from the header, wall the top, and then wall the bottom. Where I have to draw? The line should come to his face. So I cannot draw here, then it will go here. Okay. So I have to draw one line towards the eye and reflected and coming to his eye. Correct? Incident ray and reflected ray. So now I am extending the reflected ray, something like this. Next, the wall is how much meters away? D meter. So the image is also D meters. So I marked some point will be here. I know this is 2D meter away. It's exactly at 2D meter away. I want the correct position. I know this is D meter. So 2D meter away. I am drawing one line exactly like this, a straight line, 2D meter away. So this is intersecting 2 points, right? Where are the 2 points? If this is the A point and this is the B point, then this is the A dash point and this is the B dash point. Okay. Okay, next, what will do? Tell me. Huh? I need to find the size of the mirror. Okay, so what is the size of the mirror now required? I required only this much size, right? These two are the two end which is hitting, and because of this much piece size I will get this much image. So what is the object size or what is the image size? A, B is the wall, A dash, B dash is the image. Correct? I need to get something what we have done previously. What we have done previously? Get a similar triangle. One upper triangle, one lower triangle. Can you tell me one upper triangle will be here? I can take this as an upper triangle, right? This is an upper. The man head to this line. For example, I am taking this line. This line. This height I know this is called 2D. From here to here it's called 2D. So this one I can take it as an upper triangle, right? So this is the height of the mirror. This is given as X. Okay. So this is 2D meter. This is how much meter? D meter. Now this similar triangle we have drawn here. So same thing previously. A dash and this point I don't know, I am giving as O. So A dash O and here we have X. What is this distance? This is the total distance is how much? 3D. Here how much? 2D. Here how much? D. Now similar triangle concepts. Okay, tell me the similar triangle. A dash O whole divided by X is equal to 3D by D. Good. 3D by D. So A dash O is equal to how much? 3x. I got it. Okay. Next I want what? A lower triangle. Okay. So I'll do a lower triangle also like this. Tell me what is a lower triangle? OB dash. So O to B dash. B dash is extending and going here, and this length given as Y. So this length will be given as Y, and this O B dash, and this length is 2D, this length is D. Tell me, OB dash divided by Y, height difference, height, similar triangle concept, is equal to, tell me, full length divided by this length. How much will come? 3D by D. So OB dash is equal to 3Y. 3Y. So 3x plus 3y is the height of image. Okay, so I am writing 3x plus 3y is equal to height of image. Correct? Height of image. In a plane mirror, height of image will be equal to height of object. What is the object height which is given will be there? H. Height of object. Correct? So what is the size of mirror is required? Size of mirror is equal to x plus y, which is equal to h by 3. So 1/3 the size of object is required to get the full image. It depends upon the question, answer will changes. They didn't get a half. Okay. Do you know where this question is asked last time? JEE Advanced Examination. Okay, now I'll ask one. This is finished, understood? Then I will give one question, you have to answer. A man is standing. A man is standing. A man is standing at a distance of a meter from a wall. A meter from a wall. A, small letter A. A man is standing at a meter from a wall. A meter away. He is standing. Okay. B meter in front of him. B meter in front of him, a plane mirror is placed. Wall, and B meter in front of him, a plane mirror is placed. What is the minimum size of the mirror required? What is the minimum size of the mirror required to see the full wall? To see the full wall. To see the full wall. So things are different. Earlier he is staying exactly at the midway. Now he is not at the midway. So A, B things will be coming to picture. Draw the diagram. Do not turn the pages back. Do not look into what you have drawn before. Okay, just think, place wall, man, mirror. Then wall to man distance is a meter, man to mirror distance is a meter. Two lines are required. From the wall top, one line is coming to his eye. From the bottom of the wall, one line is coming to his eye. Both are extending, and images are located at a distance of a plus b meter towards right side. So you can form an image. Take upper triangle, lower triangle, apply the similar triangle concepts and find the answer. Steps I told it. Nobody will tell you steps. Even I also told you steps. Correct? Simple, but our order. These are the methods. Nothing else. These are my questions. Incident ray, reflected ray. Reflected ray will comes to I. Then we know image is at a distance of how much meter away? A plus B meter. So A plus B meter will point it to a straight line cut. How do you will get maybe the height AB in kodutena, a wall will become A dash B dash, you will get it. Okay. Then run the triangle concepts. Then we have to find it. A plus 2B, yeah? Okay. We'll see, I don't know. The answer I didn't remember, question I don't know. We want X plus Y. Do it slowly, we have enough time. Study is a slow process, writing exam is a fast process. Correct, Aishwarya? Correct. HB by A plus 2. Correct. Slow പഠിച്ചാൽ പോലും ഫാസ്റ്റ് പഠിക്കக்கூடாது. Okay. Physics maybe 100 problems பண்ணதுக்கு one day எடுத்தாலும் no problem. But how you are studying is important. By heart erudhu. So time consuming subject ആണ് physics, physical chemistry. Organic പിന്നെ കുറച്ച് logic ആണ്. Excellent. See here we don't want to by heart anything. Correct alla? Some logic. Biology lalla evlo by heart animal kind ella eduthina flat. How many phylums, how many things, any things you have to learn. Here nothing. Simply you have to know how to learn. Engineering, architecture. Just like this only. Evlo answer? A plus 2B. HB divided by A plus 2B in very answer. If you are solving, don't hurry, solve it slowly. Upper triangle edukka, lower triangle edukka, then solve it. Previously we have D meter as a way. Now we have A and B. Parameters are changed. Got it? Correct. In upper triangle, upper triangle na. This is upper triangle. Upper triangle A dash B dash. This is upper triangle. A dash B dash. Lower triangle E distance on A. E distance on അപ്പോൾ ഈ ഡിസ്റ്റൻസ് എவ்வளോ അതായത് ഒബ്ജക്റ്റ് A plus B ആണ് ടോട്ടൽ ഡിസ്റ്റൻസ്. ഓക്കെ, അപ്പോൾ ഈ ഡിസ്റ്റൻസ് എടുക്കുമ്പോൾ അതായത് ഈ ഒരു പോയിന്റിൽ നിന്ന് ഈ ഒരു ഡിസ്റ്റൻസ് എടുക്കുമ്പോൾ ഇത് B മീറ്റർ അവേ, ഇത് ടോട്ടലി A plus B ആണ്. അപ്പോൾ ഇത് എവിടെ വരും? അല്ല, കൺഫ്യൂഷനായി. ഐ ടേക്ക് ഇറ്റ് A dash B dash. കറക്റ്റ് അല്ല? ഇതാണ് A, ഇതാണ് B, അതാണ് ടോട്ടൽ A plus B എന്ന് പറയുന്നത്. ഈ മിററിന് ഇതാണ് മിററിന് ഈ ഡിസ്റ്റൻസ് എவ்வளோ? A plus B. ഇനി ഇത് ഇങ്ങനെ നമ്മൾ പോട്ടത്. സോ ഈ ഡിസ്റ്റൻസ് എவ்வளோ വരും? B അവിടുത്തെ. ഇനി ഈ ഡിസ്റ്റൻസ് എவ்வளோ? X. സോ A dash B dash divided by X will be equal to total length. Total length എടുക്കണ്ടേ? A plus B plus AB. A plus 2B. Total length divided by X in the length B. അപ്പോൾ A dash B dash dash will be equal to a plus 2b by b into x. ഇനി ലോവർ ട്രയാങ്കിൾ ഇവിടെയാണ് ബി ഡാഷ് കൊടുക്കാം, ഇത് നമുക്ക് ഒ എന്ന് കൊടുക്കാം. അപ്പോൾ ഈ പോയിന്റ് ഒ, അപ്പോൾ ലോവർ പോയിന്റ് അപ്പർ പോയിന്റ് ഒ, ലോവർ പോയിന്റ് ബി ഡാഷ്. ഈ ഡിസ്റ്റൻസ് എவ்வளോ? മിറർ എന്നുള്ള ഡിസ്റ്റൻസ് ഇതാണ് മിറർ, ഇതാണ് മിറർ. ഈ ഡിസ്റ്റൻസ് എவ்வளോ? എ പ്ലസ് ബി. ഈ ഡിസ്റ്റൻസ് എவ்வளോ? ഇല്ല, ഈ ഡിസ്റ്റൻസ് എவ்வளോ? ബി, ബി. അപ്പോൾ ഒ ബി ഡാഷ് ഡിവൈഡഡ് ബൈ ഇത് വൈ, വൈ ഈക്വൽ ടു എ പ്ലസ് 2b divided by b into b. So OB dash will be equal to a plus 2b divided by b into y. മിററിന്റെ ലെങ്ത് എவ்வளோ? x plus y. x എவ்வளோ? y എவ்வளോ? OB അല്ല a dash b dash ഇവിടെ വന്നില്ലേ, ഇതിന്റെ ലെങ്ത് x plus y ആണ്. അപ്പോൾ ഇപ്പോൾ സൈസ് ഓഫ് ഇമേജ്, size of image a dash b dash plus ob dash, a dash a o o o അല്ലേ സെൻറ്ററിലോട്ട് o നടക്കട്ടെ, a plus 2b by b x plus a plus 2b by b into what is this height? Height is given as h. Okay, അപ്പോൾ h is equal to a plus 2b divided by b. വലിയ കോമൺ ആയിട്ട് വലിയ എടുത്തിനാ x plus y. x plus y എന്ന് പറഞ്ഞാൽ തന്നെ സൈസ് ഓഫ് മിറർ, അതല്ലേ മിററിൻ്റെ സൈസ്, ഇതാണ് x y. ഇത് കണ്ടുപിടിക്കണം. x plus y equal to hb by a plus 2. hb divided by a plus 2b. hb divided by a plus 2b, correct അല്ലേ? a plus 2b. ഈ ക്വസ്റ്റ്യനിലെ height of mirror or size of mirror is equal to x plus y. You will get the answer as hb divided by a plus 2b. All of you got it down? Got it.
Yes, sir.
Okay. What is your name? Your name? Huh?
Akshara.
Spelling बनेगा? क्या? A क्या? S H T H. Name? Sorry, meaning? Perfect. Who proposed the name? Akshar. Understood up this concept, plane mirror. ഇപ്പോൾ പ്ലെയിൻ മിററിൽ രണ്ട് കോൺസെപ്റ്റ്, പോയിന്റ് ഒബ്ജക്റ്റ്, ദെൻ എക്സ്റ്റെൻഡഡ് ഒബ്ജക്റ്റ്. പോയിന്റ് ഒബ്ജക്റ്റ് കേൾക്കുന്നതിന് ചാൻസ് കമ്മി, but extended object they will ask you in a different way how it is connected and how it is communicated that way. Okay.